Well, we have another question here, question 5.2. The question says that, excuse me, the question says that sketched below are the graphs of K and H. Graph K has a turning point at -1, 18. S is the x-intercept of H and K. Graph H and K are intersect at T. Now, question 5.2.1. We have like, I'm gonna write here question 5.2.1. The question says calculate the coordinates of S. So I'm gonna write here S. We're looking for X and Y, the coordinates of S. So now let's see. S is over here. S is the x-intercept, okay, of both equations of K and H. So I prefer to use the equation of H because over here the equation is expressed. Okay, all the terms are given, but here we still have variables like A. I mean, even the constants A, B, C are not defined. So we're going to work out like H. I'm going to say here H. The function H is given by y equal to -2x plus 4. The fact that S is the x-intercept, it means y equal to 0. So we're gonna substitute the value of y by 0, and then we have like 0 equal to -2x plus 4. Okay, I am going to move the -2x over. That makes 2x equal to 4. Okay, so to find the value of x, it's when we will divide both sides by 2, and then we get x equal to, we get like x equal to by 2 here, and then we get x equal to 2. So therefore, the point S is the point 2, 0. Okay. Now that was 5.2.1. Now we're going to do 5.2.2. The question says that determine the equation of K in the form y equal to a open bracket x plus p to the power of 2 plus k plus q. Well, I'm gonna write the question here 5.2.2. 5.2.2. So we need to express y in the form a open bracket x plus p to the power of 2 plus q. Okay, this is what we call the turning point form of a quadratic equation. Now, as for if it was myself, as for me, I prefer to write this formula with a negative sign here. But let's leave it like this. I'll tell you, maybe you'll discover why. The points P and Q here are just the turning points of the equation. So the turning points will be like -P and then Q. Okay. So in this situation, so we need to find the K in this form. The turning points here are -1 and 18. Okay, so we will write here y equal to a open bracket x. I said here minus p. Okay, minus p is the turning point. So minus p is equal to -1, which means p is just 1. So over here we're gonna write plus 1 to the power of 2, and then plus 18. Okay, the other coordinates q, the other coordinates of the turning points. Now the equation is still not defined yet, so we're going to substitute the points in the equation. We can see the only point S is given here. We're going to sub in point S to find the value A. Now let's sub. We're going to sub S. So this will be, if we sub S, the y coordinate of S is 0, and then that's going to be equal to A open brackets. The x coordinate of S is 2, plus 1 to the power of 2 plus 18. And now this will be 0 equal to A open brackets. 2 plus 1 is 3 to the power of 2 is 9 plus 18. Okay. So that makes, if I move 8 times 9 makes 8 times 9 makes 9A plus 18. Then I can move the negative 9 over, negative 9A over equal to 18. Okay. I think you can still use this space. So we have like negative 9 here, negative 9A equal to 18. Okay. Then we can divide here both sides by negative 9. And then this will be A equal to negative 2. Then now that we got A, we can write the equation. It will be like y will be equal to negative 2 open bracket. Okay. Move it this way. Yeah, I can just write it underneath here. That's going to be y equal to negative 2 open bracket x plus 1, okay, to the power of 2, plus 18. So this is the quadratic equation in the x-intercept form. No, actually in the turning point form. Now the following question is 5.2.3. The question says that if k of x equal to negative 2x squared minus 4x plus 10, determine the coordinates of t. Okay. Move to put like that. Question 5.2.3 says that if we're looking for the coordinate of t, okay. If h of x equal to excuse me, if k of x, not h of x, but k of x equal to negative 2x squared minus 4x plus 10, so we're looking for the value of t. Now I think for sake of clarity, I just need to reproduce the same graph here. I shall put it here. Okay. So now the coordinate of t is this point over here, and now k of x is the parabola. Now it is actually the intersection of k and h, because h also, okay, we have like k of x will be y equal to negative 2x squared minus 4x plus 10. Okay. And then h of x is y equal to negative 2x minus 4. Let me double check the equation of h, no, plus 4. Okay. So plus 4. Now, if I need to find the equation, the coordinate of t, which is the intersection of the two, it means I will equate the two graphs, okay? The two equations. So I'm gonna set like negative 2x squared minus 4x plus 10 equal to negative 2x plus 4. Okay, we solve them simultaneously or equating the two equations because they both express in terms of y. They're both expressed in terms of y, as we can see there. So if I equate them, I'll move everything on the all everything on the right hand side into the left hand side, and then this will become like negative 2x squared minus 4x plus 10 plus 2x minus 4 equal to 0. So this will become, let's look at like terms. We have like negative 2x squared, and then minus, and then negative 4 and positive 2x will make negative 2x, and then 10 minus 4 makes positive 6 equal to 0. Now, okay, hold on a second. I just want to double check here. Is that, oh, sorry, it was 16 plus 16, not plus 10. Okay, plus 16. So over here, plus 16, plus 16, plus 16, and then there also it's 16. So this will become 16 plus 16 minus 4 is 12, okay, equal to 0. Now we can divide then the whole equation, because the whole multiple of 2, maybe negative 2, I can say it like that. I can divide the whole equation by negative 2. So by negative 2, by negative 2, and by negative 2. And then this will be x squared plus x minus 6 equal to 0. Okay, then we can solve this by factorization, right? So I can put open bracket here x, and then open bracket here x also equals to 0. I do that because the leading coefficient here is just 1. So I can just write this. Now let's consider the last term, which is a negative 6. So I'm gonna write here negative 6. Now the factors of negative 6 are like 1 and 6, 2 and 3, and that's all. Now the following question is to ask ourselves which couple in the list of the multiple of 6 will be equal to the coefficient of x, which is negative 1. So we can see that not this couple, but 2 and 3 will make positive 1. Okay, if we have like negative 2 and plus 3, and of course negative 2 times positive 3 makes negative 6. So over here we can place in negative 2 and there plus 3, and then this means that x minus 2 equals 0, or x plus 3 equal to 0. That makes x is equal to 2 or x equal to minus 3. Now we have like two values here. Now we can, it is obvious that t being equal to negative equal to 2 is not applicable, because t, the x coordinate of t lies on the negative x axis. Okay, so over here it's just NA. Oh, my n look, so they are not right, so NA not applicable. So x will be equal to, our x here will be equal to negative 3. Now we're going to sub this value of negative 3 in either k or h to find the y value. So I prefer to sub it in h, because here it's much quicker. So now sub it here in h, we have like y equal to negative 2x plus 4. So this will be minus 2x plus 4. We sub in the value of x, which is negative 3, and then we have like h will be equal to 10. I mean y will be equal to 10, because negative 2 times negative 3 is positive 6. Positive 6 plus 4 is 10. Therefore, t is negative 3, 10. Okay, Then we're going to take the next question must be question 5.2.4. Let's see. 5.2.4. The question says determine the value or values of x for which k of x is lesser than h of x. Okay, I'm gonna move my board over here. So uh, 5.2.4. So we're looking for the value or values of x for which k of x is lesser than h of x. Okay, we can just look at the graphs. We can just look at the graphs of the two. So now we can see that this is h of x and that's k of x. So now where will in which interval will k of x is lesser than h of x? Now okay, maybe I just need to reproduce the same diagram over here. Let's just put it over here. Excuse me. Okay. Earlier we did find it. We just did find that the point t is -310. Okay, this point here is -310, and then this point also is 20. Now the question says that we need to show those values of x for which k of x is lesser than h of x. Now k of x is lesser than h of x in this interval. Okay, because here k is less. Let me just highlight this. K is less here in this part because it's inferior to t in this interval, and then it is also lesser in this other part here. And though it's not really the graph, just put point arrows, but if you extend this, it must be something like this, and then this goes like that, you see. So it is also lesser into that interval. Now over here the x coordinate is -3 and there the x coordinate is just 2. Now we will say that it is true when x is lesser than -3 and when x is more than 2. Okay, when x is more than 2. Actually, or I mean 2 is less than x. Yes. Then we can write it as like this: x is lesser than -3, or okay, x is greater than 2. 2 less than x is x greater than 2. So this is fine. Now the following question is question 5.2.5. Let's see. Oops. 5.2.5. The question says that excuse me. In further, actually, it is further given that values of x will okay. Excuse me. I just wanna adjust this. Okay. It is said that it is further given that k is the graph of g prime of x. Now, the question says that for which value of x will the graph of g be concave up? Okay. And then B says that sketch the graph of G showing clearly the X values of the turning points and the points of inflection. All right. Now I'm gonna move my board over here. Question 5.2.5. So we over here we need to show that the X values. Okay, we're looking for the X values for which G concave up. So how can we do that? Okay, yeah, a function is concave up where the derivative is increasing. Okay, because our function here is, let's say, if k is g prime of x, if k here was like g prime of x, so in this part here the function is increasing from here all the way through -1. Okay, so in this situation we will say that the function here will concave up if x is lesser than -1. Okay, or we can write it like from -∞ to -1, because it was increasing in this interval. Oh, sorry, just want to show you the interval. From it is increasing over here all the way through -1, and then so we say those are the values of x. That was question A. Oh, I wrote already A there. Now B. So 5.2.5 B. Let's read it again. What was that about? So about it is said here that sketch the graph of G showing clearly the X values of the turning points and the points of inflection. All right. Now this graph here, the graph that we have here is the graph of G prime. Okay, this parabola here is the G prime. Now we need to find G itself. Okay, I'm gonna use my Cartesian plane. I take my ruler, and then I'm gonna draw. I'm gonna draw this. I'm gonna draw this. The vertical. Oops. Sorry, I meant to draw it over here. Let's say this is the vertical axis, and then I'm gonna take the horizontal now. Let me move a little bit down there. Okay. Now, what do we have here? Okay, what now that we have like the Cartesian plane, we need to. I want you to notice that the leading coefficients of the graph here, this graph, this is an inverted U shape. It means the coefficients of a squared is negative. Okay, or the a is negative here. Where is it? Where is it? Okay, we had it like this is the expression of this graph. It starts with a -2. Actually, the coefficient of x squared is -2 squared. This tells us that g of x, okay, will be of the form like, maybe I should, let me start saying this way. G of x, the graph of g of x will be this form or this other form. Okay, those are the graph of cubic function. how do I know it's cubic function? Because its derivative is a quadratic function. So the function itself must be a cubic function. It can be this way or this other way. Now it depends then. It has this form, increasing, decreasing, increasing if A is positive, and it decrease, increase, and decrease if A is negative. Now in this situation, we're dealing with this type of graph, okay? So we already know that it will decrease, increase, and then decrease. Now let's list some important points. The graph itself, as we've seen there, it is given by -2x². Let's see again. Let's see it again. Yes, -4x plus 16. Okay. -4x plus 16, and then this is g prime of x. -2x² minus 4x plus 16. We can find the turning points if we set, okay, you find the turning points if the derivative of the function, this is the formula, is equal to 0, okay? So now we're gonna set g minus 1 by 0 here, so this will be 0 equal to -2x² minus 4x plus 16. And then we can, I don't know if we did calculate this earlier, but let's just do it. We can divide each term here by -2, by -2, by -2, and then we will have like 0 equal to x² plus 2x minus 8. Now we can factorize this. No, we didn't calculate this. And I look at the constant term, -8. And then I say to myself, the terms that's going to be here must be +4 and -2. Okay. Therefore, x must be -4 or x must be equal to 2. So those are the values of x that determines the turning point. So my turning point, I know it must be somewhere here. So 1, 2, 3, 4, and then 1, 2. So it's somewhere here by 4 and then also by 2. Now, the second derivative of the function is that's equal to 0 is the one that determines the point of inflection. So, okay, here, let me write here, determine turning point, the TP. Now, point of inflection. The point of inflection is when f, the second derivative, f prime prime, or f second, equal to 0, okay? So over here, we already have like the first derivative, which is g prime. The first derivative, g prime, is already -2x² minus 4x plus 16. Now, the second derivative, okay, will be -4x² minus 4, okay, derivative. So we're going to do this 2 here times -2, that makes -4x, not squared, but x only. And then over here, the exponent is just 1. So we do -4 times 1 is just -4. So now this, we're going to set this equal to 0. And then this will be -4x minus 4. We set this equal to 0 because the point of inflection says that in the formula. So if I move -4x over, that will be 4x equal to -4. And then we divide by 4 both sides, we get x is equal to -1. This is the point of inflection. So it is over here. That's -4 and then -1. Now, I know that my graph must look like this. So let's draw the graph. So it will, the turning points if x is -4, we substitute its value into this equation to find its corresponding y value. Okay, or we can submit over here. Y is also given by -2x plus 1 plus 18. Okay, so sub -4 for x. So -4 for x, -4 plus 1 is -3. -3 to the power of 2 is, excuse me, -3 to the power of 2 is 9. -2, okay, times 9 will be a -18 plus 18 equal to 0. So hold on a second. Oh yeah, I submit in the wrong place. We don't submit here because this is a derivative. Okay, it must be in the main function which is not given. So we don't bother ourselves to substitute the value of 4 in any of these equations, because the main equation is g of x, not g prime of x. So we all we know is like those determine the turning points. Okay, so over here we'll have like a turning point here because the graph is decreasing, and then it must have another turning point here. Okay, and then the point of reflection. So the graph will be something like turning from here. Okay, and then turn also from there. Yes, goes like and then like that. This is the graph of g of x. Thank you.